Hello, everyone. For the last lecture of our presentation, our series, we will be talking about where where is the lesion approach. I think one of the most common questions I got asked while on my neuro term was, okay, so you have all these sensory changes, Karan, now where is the lesion? I think this is a question a lot of you will be asked, or you will find yourself asking this question. And hopefully I've talked a bit about a system and explained the different pathways and the different tracts to hopefully be able to understand and have an approach to targeting these kind of presentations instead of just memorizing a whole list of presentations. So before we go on, we need to know a bit of basic anatomy. We need to know the three main tracts. We need to know what they do. We need to know how they travel and where they travel to. Now you can try to memorize the combinations of symptoms and make a list or a table, but that's going to be very hard to do. It would take days. But I think if you just pay attention for the next 15 minutes, you'd be genuinely surprised how much you can actually get done with this little bit of information. And then you feel for a false sense of competence. Okay, this is the spinal cord. As you can see, I've really gone down to basics. So this is posterior, this is anterior. It runs all the way down your back. Cool. Awesome. Okay, let's start off with our tracts. First, we have the DCML tract, called the dorsal column medial lemniscus pathway. Now, I'll try to explain all kind of the questions that I had. I'm sure some of you may have this, some of you probably might not, but that's okay. My question was, well, why is it called the dorsal column medial lemniscus pathway? We'll get to it. So it's called dorsal column because it runs in the posterior or the dorsal column, right? These are the dorsal columns, which is why it's called dorsal column. The second half is more up in its kind of trajectory, and we'll talk about that in a second. So it carries fine touch, vibration, and proprioception. So these are the three senses carried by the DCML. Next up, we have the spinothalamic tract, or the anterolateral tract, as named just anterolateral, spinothalamic. A good way to know these tracts, especially when they have like two terms, spinothalamic, is the name actually tells you what or where the tract is coming from and where it's going. So the first half is where it's coming from. The second half is where it's going. Spinothalamic, from the spine to the thalamus, right? It runs anterolaterally and carries pain and temperature. And then you have the corticospinal. So it goes from the cortices to the spine. And as you can imagine, that's going to be sending signals down from your brain to the spine. And that's going to be motor function, right? And these are your lateral motor systems. All this makes sense so far? I hope it does. Okay, so now let's look at each one of these in a bit of detail. Dorsal column medial lemniscus. This is what's happening. We have large diameter axons because fine touch, proprioception, vibration require large diameter axons. It enters through the dorsal or the posterior horn, you can see here, and then basically merges into this highway of neurons and fibers going up. These are organized into these nice little channels that run up called a fasciculus. So each one of these is called a fasciculus. Now you'd come across a term somatotopic or somatotopic arrangement, or this is arranged somatotopically. What does this mean? It basically means that where the nerve goes really depends on which level it's coming from. So if let's say this is the very start of the highway, right? The nerves coming in are going to go in the very center, because as we see, we have stuff coming in from the side, right? So you can't have the lowermost inputs going from the side, because then, well, you can't really access the middle ones. So you first go to the middle and then eventually work your way out. So therefore, the fine touch, proprioception, and vibration fibers of the lower limbs are going to run medially, and then those from the upper limbs are going to run laterally, right? And that's exactly what it is. So we have the legs, lower trunk, upper trunk, and then arms. Does that make sense? And we've broadly classified these into two groups. We have the gracile fasciculus and the cuneate fasciculus. Gracile, I don't like to think of it this way. What I was taught is like gracile, like gracious, and like gracious legs. I don't know if that's wrong to even it's wrong to even say that, but oh hey, that's just, I guess, a memory tool if you want to use that. And then you have the cuneate fasciculus that's going to be composed of fibers coming from the upper trunk and the arms. Okay. Now what's going on here? So basically just explain that. And then you've split into the gracile and the cuneate fasciculus. So everything we've done so far, I hope you understand. What's going on now? These fibers basically keep going up the same side. So they move on the same side. They don't switch, they don't cross over, they just go up. So you have this, they enter and they just go up all the way up to the medulla. Now what happens at the medulla is a bit of a crossing over. These fibers go ipsilaterally on the same side, which means same side, and they then synapse with the nucleus in the medulla. So in the medulla, you have these nucleuses, which are basically points of synapse. So you have nucleus cuneatus, which is the synapse point for the cuneus fasciculus? Wait, I forgot. The cuneate fasciculus. So the cuneate fasciculus goes up in synapses in the nucleus cuneatus, and the gracilis fasciculus synapses in the nucleus gracilis. Now, with all three of these tracts, you have two neurons, right? Because you have an upper motor and a lower motor. Sorry, you have two sets of neurons, right? So everything now, they go up, the same neurons synapse here, and then from here on, they go somewhere else. So, but until then, I hope you've understood that they go up on the same side and they synapse on the same side with the nucleuses. What happens then is you have a crossing over, all right? And they cross over medially. So crossover, 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 and then they go up from there. This crossing over, because it's medial, it's called the medial lemniscus. So this crossing over is called the medial lemniscus. Therefore, the name dorsal column medial lemniscus pathway. And once it's crossed over, it goes all the way up to parts that I don't really care about. But that's all you need to know. So enters the spinal cord, travels up the fasciculus ipsilaterally to the nucleus, decussates or crosses over through the medial lemniscus pathway, and then goes to the higher centers. And the higher center is usually the thalamus. Now we have the spinothalamic tract. So spinothalamic, again, spino from the spine to the thalamus. Now we have much smaller axons, which are responsible for pain and temperature. And instead of basically going up and decussating or crossing over at the medulla, they basically cross over pretty soon. So this is usually done within 1 to 2 spinal levels of entering the spinal cord. And they basically cross over, go to the other side, and then go up the anterior lateral pathway. It then moves up to the thalamus and eventually to the somatosensory cortex, where you have your centers for sensory centers for pain and temperature. And then you have the precentral gyrus, which modulates it along the way. Don't need to know about that. But all I need you to know is it enters from one side, crosses over almost immediately, then goes up to the thalamus, and then to the somatosensory cortex. Then you have the corticospinal tract. So this goes from your cortex to the spine, right? I hope you all know at this point that most motor impulses start in the primary motor cortex, with some of them starting in the supplementary areas. You then bunch them all together to form this big channel called the corona radiata. It passes through the posterior limb of the thalamus, which can be visualized here. Once it does so, it reaches the cervicomedullary junction, cervicomedullary, so it's at the medulla, and decussates at the medulla and then travels downward. So you have the cervicomedullary junction, comes here, decussates or crosses over, and then goes down through the lateral corticospinal pathway. So now they go down to each level, and they need to reach a second order neuron to basically transmit their impulse. Remember, here they have decussated, but they haven't synapsed. That's important to know. So they've decussated, but they haven't synapsed. And if you go back to this again, here they synapse here, and then they cross over. So just make sure that you don't confuse decussation with synapsing. I hope I haven't confused you guys. I just feel like I have, but I there's not much I can do. I'm so sorry. Okay. So now these are then traveling down the corticospinal, the corticospinal tracts, corticospinal tract. Great job, Karan. And these are obviously going to be present laterally. And they then leave through the ventral horn. So let me just draw a representation of that. This is the ventral horn, and it passes medially and then leaves. So again, as you can imagine, the first fibers that are going to leave are going to be fibers of the upper limbs. And therefore, where would you expect cervical fibers to be? Would you expect cervical fibers to be here or here? Same question with the lumbar fibers, which exit last. Where would they be, here or here? And I hope you'd be thinking, well, the first fibers to exit this way should be the cervical, then the thoracic, then the lumbar, then the sacral. And that's the arrangement. Cool. So now let's put all of this together. I know you don't think like you know much, but I promise you that you do. We have a 28-year-old woman presenting with a 12-hour history of bilateral leg weakness, numbness, no significant medical history other than an episode of painful eyes and reduced visual acuity a couple of months ago. So on examination, which is really important, so she has reduced sensation in all sensory modalities, including pain and temperature, up to the level of the umbilicus. All leg movements have 2-on-5 power with increased tone, hyperreflexia, and upgoing plantars. So the two questions is, where is the lesion and what is the lesion? Okay, let's break this down into, a few important points. On physical exam, so she has reduced sensations to all modalities. So fine touch, proprioception, vibration, pain, temperature, all affected. Leg movements, all affected bilaterally, right? She also has increased tone, hyperreflexia, upgoing plantars, all upper motor neuron lesions, which indicates that the lesion is somewhere in the spinal cord, which makes sense because, well, she's also lost everything else. So what I want you to do is I always want you to think of the 3 tracts we talked about. Wait, have I messed something up? Okay. So, sorry, I just had a brain freeze for a second there. So remember some dermatomes, the fact that everything is stopping at the level of umbilicus. Well, you should think that this is level T10 because that's where the dermatomal level, that's the dermatome level that corresponds to the umbilicus. And then start off by assessing each modality. So take a step back, ask yourself, okay, so Karan, so proprioception and fine touch, where are they affected up to? And you would say, well, they're affected to the umbilicus. Okay, now, well, where is pain and temperature affected to? Again, the umbilicus. Where is the motor strength or the corticospinal tract affected up to? Well, I can't really say umbilicus because we don't exactly have a T10 versus T11. It's not as exact, but we know that leg weakness is present bilaterally. So let's draw a picture. So at the level of the T10, you have basically shot out the DCML, both sides. You've shot out the corticospinal, the spinal thalamic. Oh, wait, sorry, 1 second. Okay, yeah. So this here is just showing what the symptom loss is. And here are our tracks. So she's lost everything below. And this makes me think, well, this is affected, this is affected, this is affected, this, everything's affected. So we have something that's affected everything throughout. So this can either be something like a cord transection with traumatic injury, but she doesn't have a history of trauma. The main thing she has is something called transverse myelitis, or inflammation of the myelin that is a transverse kind of presentation. And this is very commonly seen in conditions like multiple sclerosis. And we have a few things that lead us to MS. Firstly, she's a middle-aged woman, which is kind of your key demographic. The fact that she has a mix of neurological symptoms, including an episode of painful eyes and reduced visual acuity a couple of months ago. And what this is pointing to is optic neuritis, which is again a common presentation for multiple sclerosis. Next, let's look at a bit of a harder case. And this is where I want you to, again, think of your 3 tracts and go through them every single time. So you have a 78-year-old man presenting with a 1-day history of bad legs. Past medical history includes chronic prostatism, a two-month history of lower back pain. On exams, right leg exhibits 1-on-5 power. So right leg is short. Motor function on the left leg is intact. Sensation to fine touch, proprioception is absent in the right leg, but preserved in the left, whilst pain and temperature is decreased on the left, but preserved on the right. So this is so much, I'm so, I know what the answer is, but even reading this, I'm so confused. So the only way I'm going to remember this is by going through those individual things. So we have isolated right leg motor weakness. We have isolated fine touch and proprioception on the right, and pain and temperature is preserved in the right, but lost on the left. So motor weakness on the right indicates damage to the corticospinal tract, proprioception and fine touch, DCML, and spinothalamic. Now, the reason why you have left versus right is because of that decussation pattern we talked about earlier, right? So let's talk about that. Now, this man has isolated right leg motor weakness, right? If his right leg is affected, and we know that the lesion is somewhere along the spinal tract, is the lesion going to be on the right side or the left side? Take a second, think about it. It might be a bit confusing. Think about it. Think where the motor tracts cross over, right? I hope you're thinking, oh, Karan, you just said that the motor tracts, the corticospinal tracts, cross over at the cervico-medullary junction up in the medulla, right? So if you have weakness and after that medulla, they just go down the same pathway. So if you have damage to the right, or if you have loss in the right leg, that indicates probably that the right corticospinal tract is short. Cool. And keep thinking of it that way. You have fine touch and proprioception damaged in the right. And again, you think, well, the fibers would come up and they would go all the way up and only cross over in the medulla. So, well, if there's a spinal cord lesion, it's going to be on the same side. And again, this fits with a right-sided pathology. So you have damage to the corticospinal tract on the right. You have damage to the DCML tract on the right. And then pain and temperature is preserved in the right, but lost on the left. Now that's interesting. And now you ask yourself, well, Karan, where does pain and temperature or the spinal thalamic tract cross over? And well, you would know, because we just went through that they cross over almost immediately. And therefore, any damage to the spinal thalamic tract typically presents with contralateral signs, which is why damage to the right spinal thalamic tract would present with left-sided symptoms. So let's draw out his pattern. So let's say this is right side, this is left side. So you've shot the DCML, you've shot the corticospinal, and you've shot the spinothalamic or the anterior lateral. Everything on the left side is fine, but you have basically a complete right-sided issue. And we've drawn that out. And in red is basically what's affected. And here's just everything that's grayed out. Now, this is called a right-sided hemichord lesion. So I don't think that's a huge jump, right? I think if you logically work through that, you can tell me that this is a hemi, means half the chord's affected, the entire half. What do you mean the entire half? Karan, of course it's going to be the entire half. You can't have half of the half. Anyway, sorry, me fighting with myself. So you have the entire right half affected, and that's called a right-sided hemichord lesion. And funnily enough, we have a name for it, and that's called Bernard-Sicard syndrome. I hate eponymous names because they just confuse us. And you will probably hear the term Bernard-Sicard syndrome at some point, but all you need to know that it refers to a right-sided hemichord lesion. Now, this can be due to a few things. So transverse myelitis, one, that can damage only half of it. As we saw in the previous case, it damaged everything, but you can have damage to half. You can have a stab wound that's only damaging half. And then you can also have metastatic cancer lesions, especially if things like ovarian and testicular and prostate pathology that can present with these mets. And spinal mets is the big one we worry about. Cool. Next, we have a 26. So this was a patient who had prostate cancer that had spread to the spinal cord. And we had a few symptoms of vague prostatitis and prostate symptoms in our history as well. Okay, next we have case 3. Case 3 is of a 26-year-old woman who notices some numbness and temperature insensitivity of the right aspect of both shoulders after a particularly violent rugby game. I hope you haven't watched the lecture on congenital spinal cord defect because you might have heard what I'm talking about, but let's keep going. Over a period of several days, this numbness becomes more profound and starts to spread. And she also develops weakness in her arms, legs, and trunks. On examination, she has insensitivity to pain, temperature, fine touch, vibration, sparing only her face and the saddle area. And she has a 1/5 power in all limbs with increased tone and hyperreflexia. So again, let's draw this out. As you can see, everything here is short, right? You have everything from the neck down, except the scrotal area is spared, or the saddle area is spared. The reason you often get this with these lesions is because it has an alternate nervous supply. I'm not entirely sure as to why that happens, but I know that in some cases it can actually definitely happen. So again, stick to your 3 tracts. So she's isolated. Oh, I messed it up. I duplicated slide, but forgot to change it. Okay, this is the right one. Okay, so there's widespread loss below the level of the neck. All 3 tracts seem to be affected, but a special focus on the pattern of spread. The reason, so I'll explain the saddle pathology in a second. It also should be her, I believe. So I apologize for that. Was it a her? Was it a her? Was it a her? Move. Yes, it was a her. My apologies. So we first noticed numbness or symptoms over the outer aspect of both arms, and then it spreads from arms to legs. What could that be? So we have something. So again, if we go back to our somatotropic distribution, we know that, let's start with the motor, and then we'll talk about some of the others. With motor, where is the arm of these tracts? If we were to compress this side, are we going to damage cervical stuff or sacral stuff? And I hope you remember, because the corticospinal tract comes out like this, and the first things that are going to come out are going to be from the cervical region. So damage to this part is going to lead to damage to or loss of upper limb strength. And over time, if you end up also damaging this, you would lead to lower limb stuff. And the same exact thing happens with the DCML. So what I'm seeing here is that there was a damage on both sides to first just this part. It eventually kind of ballooned out and affected more and more things. And this is kind of what it happened. So it started off with a much smaller circle, which gradually spread, right? And this is a pattern typical of a condition called syringomyelia, where you have a cystic lesion, often after traumatic injury, typically injuries seen in things like rugby, football. And that's how it presents. It presents with progressive neurological changes, typically starting with the upper limbs, progressing to the torso and to the lower limbs. And the reason you have sparing of the saddle region is because often the most outer bits are spared, and therefore you still have intact sensation, especially with these parts, right? I hope that made sense. I'm sorry if that was a bit confusing or if I went a bit over time. If you have any questions, and I know I'm sure you have a few, please send me a message because I know this is a confusing topic. And as always, please look after yourself and please look after your loved ones.